here. So we'll start with questions from you guys. At this point, we've done, we've assigned 3 worksheets from Chapter 3, the Chapter 1 worksheet, the Chapter 3 worksheet 1, and then the Chapter 3 worksheet 3. Does anybody have any questions about any or all of those that we'd like to talk about just before we get going? Put it in and send me an email and I'll make sure I take care of it. Yes, sir. On which one? The most recent one?
Yeah, the worksheet 3.
Sure. We haven't done 2 yet. Whoever was asking. Problem set 2 is different than worksheet 2, though. All right. So if we're looking at number 6, so first thing I'm going to do is identify the midline, which tells me my value for K, my amplitude, which gives me my possible values for A, and then my period, well, this would be my period. So we're going from -1 to +3. So that's 4 pi. So my value for C is going to be ±2, but I always pick it to be positive. And last thing I need to do is figure out my H and my sign for A. So I'm going to pick, for my parent function of cosine, I'm going to use 0, 1, which is a max. And I'm going to use this one, pi comma 5, for my resultant function, and that's a max. So because I'm going max to max, that tells me the A I'm going to use is positive. And since we're going from 0 to pi, that tells me the H is pi. And now I have everything I need to just kind of put together. That ought to do me. Does that feel okay, Bladen? Did I lose you anywhere? You don't seem real convinced.
I'll take it.
It's okay? All right. I mean, if we can certainly clarify, or if I lost you someplace and go back and go through it someplace in a little bit more depth, I'm happy to do that. Just say the word, bird. Okay. Others, who else has questions? Okay, fair enough. So we're going to do one more day in section 3.1. So what we've done so far, we've done equation to a graph. So for example, we gave you like y equals -2 sine of 2x minus pi over 2 plus 1, or something like that. So to do this, we wanted to write it in this kind of general form for any transformation. So once we do that, we get our values for A, C, H, and K. We can write our transformation. And then we take our 5 key points for sine. Where's Mr. Kulik getting these key points? Where do these key points come from? Our sheet here has the reference points on it. So I just looked up on this sheet and wrote down the 5 points for sine, right? Oops, wrong page. And now we're just going to go ahead and plug these through. So 1/2 times 0 plus pi over 4, pi over 4. Negative 2 times 0 plus 1 is 1. 1/2 times pi over 2 is pi over 4, plus another pi over 4 is pi over 2. Negative 2 times 1 plus 1 is negative 1. Pi times 1/2 plus pi over 4 is 3 pi over 4. And then negative 2 times 0 plus 1 is 1. 3 pi over 2 times 1/2 plus pi over 4 is pi. And then negative 2 times negative 1 plus 1 is 3. And then 1/2 times 2 pi plus pi over 4 is 5 pi over 4. And then negative 2 times 0 plus 1 is 1. So these are my transform points that I'd be graphing. So I'm going to do each tick mark as a pi over 4. So 1, 2, 3, 4 is pi. 5, 6, 7, 8 is 2 pi. So if I plot this, then pi over 4 and 1 is here. Pi over 2 and negative 1 is there. 3 pi over 4 and positive 1. Pi, oh wait, 1, 2, 3. Oh, I put this in the wrong spot, you dumbo. Can you count today? Apparently not. 1, 2, 3, okay. All right, pi and 3, and then 5 pi over 4 and 1. So that's like 1 period of my function. But like when we talked about this last time, we said that I would ask you to fill up the space provided. So if I gave you a graph, I'd expect you to fill up the space provided. Now, I don't want to generate any more points. I'm just going to plot points based on the pattern. So the spot that I'm at is just like the beginning again. So from there, I go down and then back to the middle, then up to the top. And then if I starting here, this is kind of like the end. So before the end, we're at the high point, and then back to the middle, and then down to the low point. So it would look like that. And this is the level of neatness if you're going to hand draw your graphs in your homework. This is what it should look like. You should have a grid. You should have scales. You should have points that I can see visible. Okay? Like it shouldn't just look like a bunch of like that with no scaled anything. You know, if you just do this, like what the heck is that? I don't even know what that is. Like graphs have scales, they have tick marks, they have points plotted on them. You need to do a little bit better with the pictures we're presenting. Everybody's okay? Okay. So that was like the first day in 3.1. The second day in 3.1, we went from a graph back to an equation. So let me just pull a quick example here. Oops. So here's a graph. So again, when we're doing one of these, the first thing I want to do is to identify the midline. So it's the line that divides the graph in half evenly. So that appears to be the line y equals 2. And I know that the midline is y equals k, the formula for it, so I know that's k is 2. Then I'm going to look at the amplitude. That's like the distance from a maximum or a minimum back to the amplitude, or back to the midline, excuse me. So the amplitude there I can see is going to be 3 because it's going from 2 to 5. So the A then should be plus or minus 3. And then the period should go from like minimum to minimum. Now I notice here we have 1 before 2 pi is the start, and it ends 1 before 0, and then we end at 1 before 2 pi, so I can tell the period is 2 pi. And I know the period is 2 pi c, so it just tells me c is plus or minus 1, but I always choose the c's to be positive when I do this. So now, if I'm selecting to make a sine function, so my parent function point that I'm going to choose is 0, 0. That goes from a minimum to a midline point to a maximum. And then for my reference function, I need to pick one of these midline points. Doesn't really matter which one. For the sake of argument, I'm going to pick this one, which is at pi over 4, comma 2. I can tell that's pi over 4 because there's 1, 2, 3, 4 gets me to a full pi, right? When I look at that one, preceding it is a minimum, and following that point is a maximum. So I can tell then that the A has to be positive, and I can tell that the H has to be pi over 4. So there's that as one possible answer. If I did this as a cosine function, the point I pick for my parent function is 0, 1, which is a maximum. So in my resultant function, I'm going to pick any extreme point. So I have lots of them to choose from. Say for the sake of argument, I pick this one. That's the point 3 pi over 4, comma 5. That is also a maximum. Because we're going max to max, that tells me that the A is 3. And because the or the x coordinate is 3 pi over 4. That should be my h. So my another answer might be 3 cosine 1 over c minus x minus h plus k. So that could be another answer. Does that all seem familiar? Ring some bells? Okay. What we're going to talk about today is we're going to make this process a little bit harder because we're going to just give you a description and ask you to go to the equation. So instead of having the graph where you have all the possible information you can get, you're just going to get some limited information, and we have to sort our way through that. Or some of the other information. Sure, yeah, it could be points. It could be, like periods and amplitudes and that stuff. Could be all kinds of different stuff. So here it says, construct a sinusoid with an amplitude of 4, period of 3 pi, and passes through the point 3, 1. When we say sinusoid, what is it asking for? It's asking for a sine or cosine function, right? It doesn't care which one. Okay, so this is our first difference in the previous problems where I just wrote both answers, right? Here, we want to talk about what's going to be the easiest answer to write. It'll depend on what information is given to us, whether we want to write a cosine answer or a sine answer. Everybody's okay with that? If we are given the choice, the information that's going to tell us which one to pick is going to be the kind of point that we're given. In this case, do we know anything about the point other than its location? No, right? So we're free, with the context of this problem, to assign that point to be a minimum, to be a maximum, to be a midline point. We can put that point anywhere we want on our function. In the case that we're not specified what kind of point we're given, I want to pick to do a sine function. So I'm going to choose that whenever I'm given just a point with no other information about the point, what kind of point it is. If it's just a generic point, I'm always going to choose to make that a sine function. So just like we did before, we're going to use the point 0, 0 from our parent function. That point is a minimum to midline to max point. Because I have the freedom to choose 3, 1 to be any kind of point I want, I'm going to choose it to be the same kind of point. So immediately, what does that tell me? That the a value needs to be positive, that the h needs to be the x-coordinate, and the k needs to be the y-coordinate. Immediately I get that, all for free. So I just need to figure out the rest of A and then C, correct? So I know the amplitude is 4, which tells me that the A is plus or minus 4. But since the A is positive, I know that has to just be plus 4. And then we're told the period is 3 pi. And I remember the period is 2 pi times the absolute value of C. So if I solve this for C, I'll divide both sides by 2 pi. And then I'm always going to select the C to be positive. And now I have everything I need to write my equation, right? So y equals A sine. Now, instead of writing 1 over 3 over 2, guess how I'm going to write that? Instead of writing 1 over C as 1 over 3 over 2, how would I want to write that to make it easier? Well, 1 over is a reciprocal, right? So 1 over 3 over 2 is just 2/3. Just the reciprocal of 3 over 2. So let's do that and make it simpler. And we have x minus h plus k. That's good enough. Okay. So the big takeaway here is if you're not told what kind of point the point that you're given is, we're going to use sine as our parent function, and the coordinates of that point that we're given are our h and our k, immediately for free. Everybody's cool? Okay. Now we could do this with cosine also, but it makes it a little bit more of a hassle. Well, just really the h becomes more of a hassle. But you could still do it. I don't want to, though. All right. Our next example. We're given what appears to be not a lot of information, right? Construct a sinusoid that has a minimum value at 510, and its next maximum is at 1532. Whoa, that's not a lot, right? So what I would do is I'm going to start by just kind of drawing a picture to kind of understand what's going on. So let's say here's our minimum at 510, and here's the next maximum at 1532. Everybody's okay with that? So if I wanted to complete one full period, I'd have to do another down to another minimum, right? That would make one full period. So how much of a period do we have here? From min to max. What percent of our period do we have? Looks like half of it, right? Because if I do another one the same size, that would be the other half. Everybody's okay there? So like, just for reference here, like this is a quarter, that's a quarter, that's a quarter, and then that's a quarter. So that's 4 quarters makes one full period. So we're going from or I'm sorry, from like max to min. So we're going 1 2/4, right? Everybody's okay with that idea? Okay. And that'll be true whether you're talking about a sine or cosine. All right. So I remember that a period is going to be the distance between the x's, right? So half a period is 10 units. Everybody's cool with that? If I multiply both sides by 2, 1 full period is then 20 units, right? And I know a period is 2 pi c. If I divide both sides by 2 pi, that would give me 20 over 2 pi, or really just 10 over pi. And we'll always pick our c to be positive. So our c should be 10 over pi. So far, so good. Our midline should go like halfway in between, right? Everybody agree? Or that's like half, and that's like half. So in other words, the k is the midpoint between the max and the min. Let's write it this way. So our k should be 21. Everybody okay there? Our amplitude should be half the distance between the two. So that should be subtraction then. So the A should be plus or minus 11. Oh, you know what we didn't talk about here at the start, though, was how to pick whether we should be writing a sine or cosine function, right? So let's go back and think about that for a second. So again, we're told sinusoid. So again, we could write this as a sine or a cosine. Now, the points that we're given are mins and maxes, right? When I think about when I use the parent function for sine, I use a midline point. When I do the parent function for cosine, I want to use an extreme point. That's what we have here. So I'm going to use a cosine function. Everybody's okay with that? So whenever I'm given maxes and mins, a cosine function would be a good one to use. Again, you can do it with sine, it's just inconvenient in a way that's like tough to deal with. And now I can use either point it doesn't really matter. Let's, for the sake of argument, say we picked the maximum. So what does this tell me about the value for A? If they're both maximums. The A has to be positive. So in our case, that means it's 11. And because we're going from 0 to 15, that tells me the H has to be 15. And we're now got everything we need. So notice here when I'm about to write 1 over C, that would be 1 over 10 divided by pi. I'm going to write it that way. I'm going to write it as pi over 10, the reciprocal, right? Just to make life cleaner. It's not wrong if you write it the other way, but like, come on now, folks. Everybody feel okay on doing this? Still kind of the same thing we've been doing, right? It's just harder because you don't have a picture to look at. You have to kind of construct your own picture or piece your stuff apart from what you're given. But it's still totally doable. Not much different than what we've been doing, right? But I wanted to give another day in between this and last lesson because they blur together, right? And it's much easier to start with the whole thing, the picture, than to go just from a description where you have to get everything you need out of a little bit of stuff. So far, so good? Okay. My plan then is we're going to do, you guys should be able to work on worksheet 2 now. Let's move that there. So in worksheet 2, looks a lot like the example problems that we just did. Okay. And give you guys time here in class to do this now. This is the last thing that we're going to talk about in section 3.1, which might mean what's coming up soon? A homework quiz. So might want to be ready to do something like that pretty soon. Tomorrow, or next time in class, we're going to do have a Delta Math assignment for you and give you a little bit of homework from the homework problems. And if you need more time to work on this thing, you could spend more time working on this. But it's just kind of a general work day after we get done with our potential homework quiz. Okay? Now my suggestion to you for today, while you have a lot of time here to work, is to start with whatever feels the least familiar to you, because you can stop and ask questions of either your classmates or myself. Either is great, but try to get some stuff done today that you don't feel great about so you have an opportunity to talk to somebody else that knows more than you do and feel a little bit better about it. Everybody cool? Questions for me? Okay, very good then.